So today we'll demonstrate the installation of the Android virtual machine. So first we click new, and then from there the tab, the create virtual machine tab shows up. Then we type in the name as VM01, then select the ISO image. Then for the type we choose Linux, the subtype we choose other Linux, and we go to the hardware and set the base memory to 4 gigabytes. Once that's done, select at least 2 CPU, then change the virtual memory to 32 gigabytes, click finish, then click start. Let it load for a bit. Once the installation environment shows up, arrow down to the installation option, click enter, then let it load. Okay, once that is done, then head over to the create modify partitions to create a partition and click no. Select the OS option, click enter. And over here, just click new, enter. Leave the partition size as is, as 32 gigabytes, and click enter. After that, you head over to bootable, click enter. Now you see asterisk beneath the boot head up there. Then head over to the right option, click enter. Then type yes to make it writable. Once the next tab shows up, select the SD1 partition we just created. Then click enter, arrow down to ext4, hit enter. Then select OK, enter. Then over here, you just side arrow to yes and click enter. Once that is done, then we click no to all options, select yes to install grab bootloader. Then now we just have to wait for the installation of the Bliss OS to be installed to the SD1 partition that we've created. So we just wait for a bit. Then all we have to do now is to reboot the system. But before we do that, we have to unmount the ISO image so it won't relaunch into the installer environment again. So we first unmount to that, and now we just click OK. It will automatically reboot into the OS that we installed. Over here, just arrow down to the VM options, hit enter, then select the second option and hit enter. Then you're all good to go. So once this is done, you can see that the Android OS is successfully launched. So just select the second option, quick step, and click always hit enter to open the Android OS. And that pretty much concludes section A, part 1A of the assignment, which is to configure the virtual machine Android OS. Now we'll be moving on to the second part of part 1, section A, which is exploring the device key features of the operating system. So starting with the battery, before that, as you can see on the top at the top of the screen, we're utilizing CPU Z to monitor and view these features of the Android system. And so if we start with the battery, as per requirement of the assignment, CPU Z, it gives like real-time battery status. So if you look at the battery, like over there, it gives the current level, the charging state, voltage, temperature, and these indicators are
critical because they help you catch memory problems early, like overheating or even irregular charging behavior. So that's for that. And as for memory section under the device tab, you'll find the total RAM and how much is currently available. So in our case, total RAM is 3.9 gigabytes and available RAM is only like almost 2 gigabytes, and internal storage is 31 gigabytes. Available storage is 25 gigabytes. The RAM lets you know like how efficiently your device is using memory and whether background apps are clogging up resources. The storage, on the other hand, shows the capacity that this Android operating system can cater for new applications that you will install in this device. So, whenever you install a new application, it has to be less than the available storage of the device. Now, moving on to the performance management part of the device, which is normally found under the SOC tab. Here you can see your processor model, clock speeds for each core, and current workload. So if some cores are maxed out while others are idle, it gives you insight into how your device handles multitasking and load balancing. So that's for that. And but like for malware protection and permission control, you can use the device's security settings or Google Play Protect. Now, as for the device's security, while CPU-Z doesn't manage security directly, if you go to under the system tab, you can check the Android version, the kernel, and root status, which are useful for verifying systems integrity. Now we'll move on to section A, part 1C. So we are downloading Candy Crush, but in order to do that, we have to set up our Google Play Store. So we'll be able to do all that. So in the next 30 seconds, we'll just be setting up the Google Play Store account. Almost done. Once it is done, we want to install DevInfo Overlay, which is another app that we'll be using to monitor RAM and the CPU usage of the device. Moving on, we'll be setting up the DevInfo Overlay application. So we'll be able to see the performance of CPU and RAM respectively as we simulate the download of Candy Crush, as well as when we launch it. As you can see on the screen right now, we are setting up 2 frames, one for the RAM and the second one for the CPU. So we'll be able to track the performance as we simulate the download of Candy Crush, as well as launching of the application. So like currently we have Candy Crush downloading in the background, so you can see there's like changes in the figures within the frame right there. And let's see what happens with CPU. So like currently it's like refreshing, so when we start it, you'll see a huge spike in the figures like that. It goes from 2 right up to 80 and 70, and that's all because Candy Crush is downloading in the background. So it is still downloading. I want you to pay very close attention to CPU and RAM when the download is complete and it says installing. Okay, there, right there, see? Okay, it's gonna spike up right up to 99, and it's gonna drop back down right after that, back to like 6. Now the reason behind the spikes in both CPU and the RAM is because the system's working really hard to unpack files, verify integrity, and set up resources. After installation, you launch the game. Now memory RAM usage increases significantly, and that is evident there. And that is because Candy Crush may look simple, but it loads animations, sound, graphics, and syncs online data all at the same time. And in our case, the device is already multitasking, which can slow things down or cause app lag. But in our case, it actually stopped out. So we have to close the app and relaunch it from there. Now, and if you look at both frames of the CPU and RAM, you'll notice as the app is launching and the game is actually played, the spikes and the figures went higher and higher. So this clearly shows that how the application requires CPU and memory to be able to run smoothly and to free up memory so the game runs without interruption. This could be a potential reason why it closed out in the first place. The first time that we attempted to run it. The second one is to clear cached data periodically, and we say this because this might prevent buildup that slows down storage and memory. Three is to use the device care or optimization tools to stop, this can stop unnecessary background processes, monitor temperature, and free up system resources. And four, if like if you're someone that games a lot, consider enabling game mode or because it prioritizes performance for smoother gameplay. And our fifth take is to probably get an upgraded device with much more RAM space and storage with a better operating system. So with that concludes section A of the assignment. Pinaka.